that left Earth 65 million years ago is now 65 million light years away. So if aliens knew where to point their telescope, they could see dinosaurs. But is it possible for anyone, even a super technologically advanced alien, to build a telescope powerful enough? Light takes time to travel, so looking at anything is equivalent to looking back in time. And the farther away it is, the farther back in time you see. For example, if your eyes are about 2 feet away from the screen you're watching this video on, then you're seeing this video as it was about 2 nanoseconds earlier. That's basically instantaneous, and way faster than the human reaction time, so the light speed delay doesn't muck up our daily lives. But if you look at the moon, the light left it about a second ago, long enough for there to be noticeable pauses in communication with Apollo astronauts. For the sun, it's closer to 8 minutes, so if for some crazy reason the sun disappeared, then no one on Earth would know it for about 8 minutes. When astronomers look through their telescopes at distant stars, they're seeing them as they were many years ago. Coincidentally, this is one way astronomers measure distance. A light year is just the distance it takes light to travel in a year, conveniently tying distance and age into one number. So again, in theory, the light that left the Earth millions of years ago is now millions of light years away, and in that light is a glimpse of dinosaurs. Since the dinosaurs went extinct 65 million years ago, then the closest alien that could see dinosaurs, if he knew where to point his telescope, is 65 million light years away. But in practice, it's much harder because the Earth is small and 65 million light years is a long distance. For perspective, the vast majority of the visible stars in the night sky are within about 1,000 light years of us. The Milky Way is about 100,000 light years across. The nearest galaxy, Andromeda, is about 2.5 million light years away. At 65 million light years, our alien astronomers would be in the far-off Virgo cluster of galaxies. So, if these aliens want to see dinosaurs, they're going to need a big telescope. Human astronomers can only barely resolve nearby planets in our own galaxy, let alone extragalactic planets. In fact, only a handful of observations have been reported of extragalactic exoplanets. One is the Andromeda, and the other is Cheating. It's only 2,000 light years away from Earth because it was acquired by the Milky Way in a galactic merger. So how do telescopes allow us, or aliens, to see across the universe? Consider an analogy. Imagine the sun is constantly casting an enormous barrage of little tiny bouncy balls in all directions. These balls are photons, or individual particles of light. On Earth, some will bounce off of a T-Rex and then get caught in your eye, so your brain will be able to register, oh, that's a T-Rex, I'm going to die. The farther you are from the T-Rex, the fewer balls make it to your eye, and so the harder it is to see the T-Rex. Some other balls will hit the T-Rex and bounce up and off into space to travel the universe. Telescopes are lenses and mirrors to refocus a bunch of those space balls over a wide area to a small collector so that we can get the benefit of a really big eye, and the farther you want to see, the bigger an eye you need. So how big does an alien telescope need to be? Fundamentally, a given lens can only focus light so well due to quantum properties of light. No matter how super intelligent these aliens are, they can't cheat fundamental physics. Using what we know about the resolution limits of man-made lenses, physicists can calculate that a lens would need to be over 36 million miles across, which is about a third of the distance to the sun. This lens would fill up about half of Mercury's orbit, and it would only give the aliens a view of the Earth as 1 pixel. And if that wasn't impossibly huge enough already, these aliens wanted to see dinosaurs, not just the Earth. If you want to resolve a dinosaur, even as just a dot, then the telescope lens needs to be much bigger, 4.4 light years across. Such a telescope would fit comfortably between our sun and the nearest star system, Alpha Centauri. Human astronomers often give their telescopes hilarious names like the Very Large Array and the Overwhelmingly Large Telescope, but somehow these just feel inadequate. We don't have to sit around and debate whether or not an alien can build a telescope this big. Einstein's theory of relativity actually gives us the answer. General relativity tells us that matter curves spacetime, and the more mass you have, the more it curves space. If you put enough mass in one spot, the spacetime curvature will be so extreme that it must collapse on itself, forming a black hole. In fact, a ball of glass 28 light minutes across will have enough concentrated mass to collapse into a black hole. So yes, in theory, the view of a dinosaur is out there in space, but sadly, no aliens will ever get a glimpse of them.